Hello, this is register number URK17CS183 and today I will be demonstrating our lab experiment number 9, multi-threading. So here we have to depict the producer-consumer problem where in this case producer produce a data and then consumer check if the data is available or not and consumes it. So if there is no data, consumer cannot consume anything. So let's directly see our program. In this program I have created a class name stock, will come to that later, an object of it, and here I've created thread 1, and inside that I've used the predefined function, and which is like interface takes method. Sorry, I've used a predefined method from interface name runnable, and here we have implemented it inside the thread, and we have used this method to we'll see later how we've used this method, but we have given our own input, and similarly I have created a second thread also in the same way, and here we are using the get method. So here this part is going to play as a producer part and this part is going to play as a consumer part. So as you can see here, we have also given this thread T1 as name as producer and T2 is set name as consumer. So both of them we have started the thread. And inside our class stock, initially we are putting the stock value to 0 because it's going to start from 0, and we are setting the boolean flag equal to false. So in first case, suppose we have a stack over with us. Okay, let's assume it, we have a stack with us, and then in that particular time the stack have the processor. Okay, and first of all the producer will check if it's not full or not. So we have set it as false, so it won't go to waiting period, means it won't wait for the consumer to consume whatever is in the stack, but it will directly set the flag as true because particularly for current position producer is using that stack, and it will give that stock value as I, and simply it will put that stock inside. And here we have used notify function. So what does notify do is like basically it notifies the other side. So this particular part means producer will notify the consumer that it have done using the stack and now it can consume whatever is inside the stack. So as you can see here, we are setting the flag equal to true here and stock value, and it will display accordingly. We'll see, come to the display part later. And then we have here get method, and in get method we have if not equal to flag, means this is true. Okay, so if this was false, it will enter this loop and it will wait. So means that producer is not done with its work and the consumer have to wait. So it's obviously true, then it won't enter this place and directly it will go to consumer and consumer will consume. And now consumer will again set the flag to false and it will notify to the producer that it has consumed whatever is inside the stack and now it can produce again. So we have like created this pattern so to solve the producer consumer problem. Once the producer is finished producing, then only consumer can consume that particular thing, and if there is nothing to consume, then obviously then consumer will not generate a thread. So just for the sake of understanding this more deeply, so here what producer is doing, it is after producing something, it is setting the flag as true. That means there is something to consume. What if I set this as false? So as you can see here, in this condition we are getting the producer consumer completely in synchronized manner. But what if I put flag as false? So now as you can see, there is no consumer. So because producer is not notifying that it has finished producing something, the consumer cannot consume anything. So it is thinking that there is nothing in the stack and it is not able to consume. So it keeps on going in the waiting period and producer have all the outputs done. So as you can see now, if I put it as true, then it is working perfectly fine. So this we have one more keyword here, synchronized. So we use synchronized keyword to generate it in an orderly fashion. So if we remove synchronized from this both the classes and run it again, so as you can see, it will create an error. Okay, because if this particular task is not synchronized, then there might be a chance if producer produce 0 and after that at producer didn't produce 1, but consumer is going to ask for the data 1 which is not existing in the stack, so obviously it will create an exception. So that is the problem that is going to be generated here if we don't use synchronize. So as you can see, we are going to use here synchronize and our program is successfully compiled. Our lab experiment number 9 is successfully been completed. Thank you so much for watching.